Bill Nye discussed a surprising discovery from Voyager 1, a spacecraft that has been returning data to Earth for more than 47 years. Its most recent discoveries may alter our opinions about space exploration and space travel. The spacecraft was initially launched to investigate far-off planets, but it is currently exploring deep space and has found that the region between stars is full of surprising particles and activity. Be ready. What Voyager 1 has shown is only the beginning of what lies ahead, and the discoveries we're about to uncover may completely change how we perceive the cosmos. Bill Nye recently revealed that, following 47 years in orbit, Voyager 1 made a finding that defied all expectations. The spaceship was first sent to explore the outer planets. It now stands for both human curiosity and technological advancement. It is now investigating the deep regions of space between stars. The journey's discoveries underscore the extent of uncharted territory in the universe while also paying homage to the original engineer's goal. As we get ready to share the incredible discoveries Voyager 1 is about to reveal, secrets that might completely change our place in the universe, stay tuned. Voyager 1 has been traveling away from Earth for nearly 50 years, visiting regions of space that have never been visited by any other spacecraft. Earth scientists are in a state of amazement at its latest discoveries. It has seen phenomena in space that defy the accepted understanding of physical principles. This serves as a reminder of just how amazing it is that Voyager 1, which was only supposed to operate for 5 years, is still sending intel. The fascinating thing about the new data is that it raises the possibility that we should reconsider some of existing space models. Voyager 1 entered the interstellar medium, or the region between stars, as it passed beyond our solar system's outer planets. Voyager 1 discovered something surprising in what scientists had previously believed to be an empty space. It found an area that was full of dust, particles, and radiation from distant stars. Voyager 1 discovered an area that was significantly denser and more active than the frigid, empty void that scientists had imagined. There are enormous ramifications to this discovery. It implies that the distance between stars is significantly more intricate than previously believed. This might alter our plans for next space missions, necessitating the development of new propulsion and protection technologies. It also suggests that there may be unidentified forces operating in these far-off places, which begs more concerns about the formation of the cosmos. Bill Nye emphasizes the significance of Voyager 1's mission since it continues to yield new insights about the nature of the cosmos. Every bit of information the spacecraft transmits advances our knowledge of the universe's true nature. Comparable to a storyteller, Voyager 1 reveals truths about the universe that we are only now starting to learn. The startling thing is that, despite being more than 14 billion miles from Earth and constructed using technology from the 1970s, Voyager 1 is still operational. The relevance of the golden record on board, which was intended to serve as a message for any extraterrestrial civilizations that might stumble upon it, is increased by this continuous connection, which also questions our conception of space. Voyager 1's findings indicate that the cosmos is far from empty and may perhaps be teeming with life, even if it seems doubtful that extraterrestrials will ever come across the spacecraft. The remarkable discoveries made by Voyager 1 and its continuous journey serve as a constant reminder of humanity's never-ending quest to explore and comprehend the cosmos. Its continued journey away from Earth deepens our understanding of the universe and highlights the value of long-term scientific expeditions in solving its many mysteries. Great discoveries take time, as Voyager 1 reminds us in an era where results are expected quickly. Since its launch over 50 years ago, it has outlived the projected duration of its mission, astonishing successive generations of scientists with findings that cast doubt on our comprehension of the cosmos, such as the unexpected particle density in deep space. Voyager 1, which was initially launched to take pictures of Jupiter's storms, has now reached the farthest reaches of the solar system, becoming the first artificial object to do so. This spacecraft, which is still in service, sends important data back to Earth every day from the 1970s, keeping scientists busy and advancing our understanding of the universe. With every step Voyager 1 takes towards deeper space, scientists anticipate seeing what new discoveries it may make. Its voyage is far from ended, and it is already upending our preconceived notions about the cosmos. Despite its outdated technologies and limited power, It continues to further our understanding by revealing what life is actually like in the furthest reaches of space. With a clearer understanding of what exists outside our solar system, these findings might aid in the planning of future space expeditions. The incredible thing is that Voyager 1 is still operating and returning data despite the harsh circumstances in space. Not only does this spaceship teach us about space, but it also represents human curiosity and the urge to explore. It is not only altering our understanding of science as it continues on its extraordinary trip, but it is also demonstrating the lengths we will go to in order to learn new things. Using technology from the late 20th century, this spaceship has surpassed all expectations. Voyager 1 was initially intended to research the outer planets, but it has since pioneered deep space exploration. Bill Nye draws attention to the most recent findings, which are revolutionary for science, as well as for our understanding of space and our place in it. The difficulty of space travel is demonstrated by the fact that Voyager 1 continues to function in spite of the harsh circumstances it encounters. It faces cosmic radiation and temperatures that are almost as low as zero outside of our solar system, but it continues, providing us with ever greater insights into the cosmos. Voyager 1 is continually delivering data to Earth despite its advanced age and depleting fuel. Its systems continue to function even though radiation and the severe environment may have caused harm. Its resilience enables it to continue making significant advancements in our comprehension of space. It demonstrates that a well-designed spacecraft may flourish in the harsh circumstances of deep space, in addition to surviving them. Voyager 1 signals take more than 20 hours to travel over 14 billion miles to Earth, yet they nevertheless include important data. This alone is a tremendous accomplishment that demonstrates the engineering prowess of the spacecraft's designers. Despite using technology that is today considered antiquated, their efforts have allowed this mission to be among the longest and most prosperous in space history. Voyager 1's recent discoveries have shown a surprising amount of particles in the interstellar medium, the region between stars. This is one of the biggest surprises. Scientists predicted that there would be far less particles once Voyager crossed the heliopause, which is the boundary where the sun's effect ceases. However, Voyager 1's data reveals that there is far more plasma, a charged gas, than previously believed, which has caused scientists to re-evaluate their theories about space. New questions are raised by the discovery of this dense region. What is the greater density caused by? Do these particles interact with magnetic fields, or is there another mechanism at work that we are not yet aware of? Scientists have been debating this a lot, and it has caused them to re-evaluate their assumptions about what they knew about space travel outside of our solar system. Formerly, scientists believed that there were only a few atoms floating around in the almost empty space between stars. However, Voyager 1's discoveries imply that space is more dynamic and complex than that. This suggests that processes that we currently don't fully understand may have an impact on the universe, at least in the regions between stars. Scientists are now debating whether Voyager happened to go through an exceptionally active region of space, or if this high-density area is usual. One possibility is that the solar wind's interaction with the interstellar medium is what's causing this higher density. It was anticipated that a quieter region would result from the solar wind, a stream of charged particles from the sun, slowing down beyond the heliopause. It appears, nevertheless, that this barrier may be more of a bustling, dynamic frontier where the particles between stars and the solar wind converge, creating denser material pockets. According to some experts, the data from Voyager may first even reveal the consequences of far-off supernova explosions or other significant cosmic events. Even though these explosions occur millions of light-years distant, they have the potential to cause shock waves that could change the particle density near Voyager 1. If this is accurate, Voyager may first be providing the first direct measurements of the effects of big events, such as supernovae, on the interstellar medium. These results may contribute to our understanding of the evolution of galaxies in addition to improving our understanding of the interstellar medium. The interstellar medium is essential for the formation of stars and for determining the behavior of galaxies. Higher density in some regions might alter our understanding of galaxy creation and evolution and provide new information about how galaxies, including our own, evolve over time. Future space missions may need to be planned differently if space is denser and more active than previously believed. spacecraft may require more sophisticated equipment to handle higher particle resistance in a denser interstellar medium. The discovery made by Voyager 1 not only modifies our understanding of space, but also influences future research tactics. The finding of a higher particle density raises the possibility of unanticipated difficulties for upcoming spacecraft, especially with regard to sensor and electronics protection. This highlights how crucial it is to have sturdy shielding for extended operations. Furthermore, this knowledge forces us to reconsider how we conceptualize space. What we had believed to be primarily empty space between stars is in fact dynamic and intricate. This may indicate that there is greater connectivity between our solar system and the galaxy than previously thought. In addition, the results from Voyager 1 have sparked a renewed interest in cosmic rays, high-energy particles that originate outside of our solar system. These cosmic rays can seriously harm both humans and spacecraft. Voyager 1 might be traveling through regions with higher cosmic ray concentrations because the interstellar medium is denser than anticipated. This implies that if we wish to send humans on lengthy space missions, we must give careful consideration to how to shield astronauts from these dangerous rays. The future of space travel is being shaped by the lessons learned from Voyager 1. There's a plea for more funding for extrasolar missions as we learn more about the intricacies of space travel, highlighting the importance of exploring uncharted territory. This has spurred enthusiasm in designing more sophisticated missions with better instruments to further our comprehension of interstellar environments. While examining Voyager 1's data, scientists are also thinking about the new technology that will be required for these trips. Travel times to the closest stars might be shortened by technological advancements like enhanced ion drives or even theoretical warp drives. Though it may sound futuristic, Voyager 1's unexpected discoveries point to a lot more surprises to come, indicating an exciting future for space research. The findings of Voyager 1 indicate that space outside of the heliosphere is significantly more dynamic and complicated than previously believed. Previously, scientists believed that this region was peaceful and largely deserted, but it now appears that unexpected processes and forces exist here. This new perspective on interstellar space indicates that significant technology advancements will be necessary if humans hope to travel between stars in the future. In the ensuing centuries, these developments may create new avenues for human space exploration. How much international cooperation is necessary for space research is another crucial lesson to be learned from Voyager 1's mission. Voyager 1 serves as a reminder of the worldwide endeavor to comprehend the universe as it travels farther into space. International scientists are collaborating to examine the data it returns. In order to plan even more ambitious missions that reach beyond our solar system, this cooperative spirit will be crucial. Findings from Voyager 1 have also rekindled interest in the hunt for extraterrestrial life. The Golden Record, a message intended for any extraterrestrial culture that may stumble upon it, is kept on board the spacecraft. Some scientists speculate that there may be more locations that potentially support life in space as a result of these recent discoveries, which demonstrate that space is more dynamic and complicated. The data from Voyager 1 provides scientists additional cause to search even though life hasn't yet been discovered. The mission of Voyager 1 not only astounds us with its findings, but it also challenges our preconceptions about the direction of space travel and humanity's place in the cosmos. The spaceship is pushing the boundaries of our knowledge and inspiring us to dream of traveling even farther as it travels into areas of space that no one has ever visited. Voyager 1 is teaching us valuable lessons that have the potential to transform our understanding of science, technology, and even the cosmos. Our perception of space has been drastically altered by Voyager 1, which showed us that it is a dynamic, interactive environment rather than a silent emptiness. This insight shows that star spacing actively affects galaxy evolution, with profound ramifications for astrophysics and cosmology. When Voyager 1 left the solar system, it encountered abrupt and powerful magnetic forces in interstellar space, which cast doubt on earlier theories about the safety of space travel and suggested that this area might be more dangerous than previously thought. The spacecraft's observations also imply a denser and more active interstellar medium, which calls into question the conventional wisdom regarding the formation and evolution of galaxies. Our understanding of the interactions and complexity of the universe is changing as a result of these discoveries. Once they leave the sun's protective shell, future spacecraft, especially those intended for manned missions, may encounter more difficult circumstances than anticipated. Strong magnetic fields and a rise in cosmic rays could lead to higher radiation and particle hits, which could harm spacecraft equipment. For further space flights, engineers will need to develop more robust shielding in order to be ready for these obstacles. Even though modern spacecraft are designed to withstand harsh environments, Voyager 1's discovery of denser regions may need for even better materials to shield against stronger cosmic rays and particles. In order to better safeguard astronauts and spacecraft against the growing threat of cosmic rays, which can be hazardous to technology and human health, scientists are creating new materials. These particles are protected from us in our solar system by the sun's magnetic field, but they can still harm spacecraft electronics outside of the heliosphere and result in malfunctions or system failures. Engineers are concentrating on using radiation-resistant components and building spacecraft with improved protective layers in order to safeguard long-duration space missions. It is much more dangerous for astronauts. Cosmic ray exposure over an extended period of time can raise one's risk of cancer and other illnesses. Creating a shield around the astronauts' living quarters with substances like water is one way to keep them safe. The real-world cosmic ray data from Voyager 1 will be useful to scientists as they determine the best ways to safeguard personnel on deep space journeys in the future. The main revelation, though, is that Voyager 1's discoveries are making us reconsider what space actually is. Our conception of space as merely the voids between planets and stars is completely altered if it is more dynamic and interconnected than previously believed. It's possible that space itself has a significantly greater influence on the universe's formation. This new knowledge may force us to reconsider our place in the cosmos and the role that space plays in everything from star formation to galactic activity. The findings from Voyager 1 show that rather than being empty and immobile, the space between stars is dynamic and active. This may affect interstellar behavior and has consequences for our understanding of dark matter, the enigmatic substance that makes up most of the mass in the cosmos. These results underline the importance of long-term space missions by showing that even older spacecraft, such as Voyager 1, can yield groundbreaking knowledge and serve as an inspiration for future designs of more robust space exploration. We believe that as we continue to push the limits of our understanding of space, more missions will build on the legacy of Voyager 1 and conduct deeper space exploration. Maintaining contact with Earth as Voyager 1 gets farther and farther away is one of the most difficult aspects of the project. Because of its extremely feeble signals, which take over 20 hours to reach us, scientists have had to devise ingenious methods for gathering and analyzing the data. Future missions that venture farther into space will only make this issue worse, necessitating the development of new technologies like laser communication systems in order to transfer data over such great distances. The goal of Voyager 1 has also generated a great deal of interest in the application of artificial intelligence, AI, and self-governing systems to space exploration. Controlling spacecraft in real time becomes impractical as they get farther away because of the time it takes for signals to travel back and forth. This implies that we will require spaceships capable of independent thought, including the ability to assess their environment, come to independent conclusions, and handle unforeseen issues without assistance from humans. Are there any undiscovered hazards that we should be aware of as we venture further into the unknown? Please remember to use the like and subscribe buttons if you enjoyed this and want to see more.